Hi, this is the FLL Mentor channel. Our goal is to provide tips, tricks, and advice for FLL robotics. Please support this channel by liking this video and subscribing to us on YouTube. You can also follow our Instagram and Facebook page, which is the FLL Mentor. Today, we will be discussing how to begin designing and building your robot. Designing your robot is one of the most difficult and time-consuming parts of FLL, and it can be very complicated and frustrating. Hopefully, this video will help your team and you simplify the process. In this video, I'm going to talk about designing your robot. Remember that I'm not talking to you about how to design your run. Today is just about literally designing your robot, and I'll talk about how to design your run in a future video. Process. Before you start sticking pieces onto your EV3, it's crucial to plan everything out. Building your robot challenges are super fun and easy. But although building your robot should be fun, there aren't any instructions for this task, and it's difficult. Before I talk about your robot design though, I'd like to recognize the importance of actually creating a robot, not just using one that's already built. I know many teams that have had one robot that they always use. This is usually one exact copy of one of the standard EV3 designs. These teams never make any changes to the robot, not even when a new season begins. This is not only very frustrating to teams who take the necessary time to design and build a robot, but it's an absolutely terrible way of promoting creativity and encouraging teammates to work together. FLL is specifically designed to incorporate core values into every aspect of robotics, especially the robot design and the building. So teammates, mentors, and coaches, please start from scratch. Even if you already have a perfectly working old robot, it's very important to your team's development, and it's part of FLL, because many teams who are just starting already have to build a new robot, and it's fun, and it's a way to practice these core values. Anyways, I recommend that you have a working EV3, all the necessary motors, sensors, and wires, and an abundance of LEGO Technic pieces, which are a category of pieces that are best for robot building. You'll also need some sort of laptop computer and a cable that connects to your EV3. If you don't have any of these things, you're pretty much going to have to purchase them or borrow them from other teams. If you need pieces and an EV3, I recommend that you buy the LEGO Minstorms Education EV3 core set, and I put the link in the description so you can check that out if you need it. Once you have all of these parts, it's time to start thinking of how you're going to put them together in order to create a robot. To do this, there are several things you must base your design about. First, challenges. Your robot needs to be agile enough to move to them and in between the challenges, and it also needs to be able to complete the challenges. So when you first get your, the challenges first come out, you can look to see what type of motion do you need. Is there a button that you need to push? Is there something you need to pull? Do you need to be able to spin something? Look at the different types of physical things that the robot needs to be able to do. Second thing, speed. Your run is 2.5 minutes long. Your robot needs to be accurate, but also fast so that you can get as many points and as many challenges done in this time. 3, variables. It's super important to know this. You want to eliminate as many variables as possible. This has to do with your design, but it also has to do with your code, which we'll talk about in another video. So, when you're creating a robot, try to simplify it down to where you don't have to depend on chance or probability that something can happen. It should happen every time. Eliminate variables. 4, your setup. The only time your team can touch the robot without a penalty is when it's in the starting area of the board. It needs to fit in this area, and if it requires modification like a part changing out, this should be easy and fast. I'll talk about this later, but there's different ways to make really great attachments that you can just pop on super simply. And if you need help doing this, not only can you email me, but you can just search on YouTube some different interesting attachments from previous years. 5, the brain. What should the robot know? Where can you use sensors? How will it use these sensors? When you first get your robot mat, or if you don't have it, you can look up previous year's robot mats online, but it has these basically big black lines or different colored lines, and different like colors all around the board. And this is so that you can use color sensors. They don't just put it there randomly. So not only will this score you points in robot design, because the judges will be impressed that you're using color sensors, but it helps your robot be super accurate and do things that you wouldn't be able to do otherwise. 6. Parts. What individual parts are best for what I'm trying to do? Usually the answer to this is Technic pieces because they're sturdy, but sometimes I have seen robots that use a lot of just plain Lego pieces too, so just make sure that you just pick the pieces that are going to be most sturdy for your robot. A lot of younger kids are doing this and like play with Legos and stuff like that. Try to move away from the like playing part of it and try to focus on like engineering and design and try to create the most sturdy, best thing so that one, when you run it, it'll stay together, but two, when you have to transport it to different events, it'll stay together. So once you consider all of these things with your team, it's time to start thinking of the best sort of design. Because there's so many challenges made for the board each year, I'll explain the process through example. So the year I'm going to be talking about was Trash Track, and my team's old robot was called Points. In this year, Points had a huge, clunky forklift-like attachment that seemed to break every time we used it. We were it was called Trash Track, and we were trying to think of things that are already used in the world of, trash and waste. So we created a forklift so that we would have sort of this motion, and it wasn't very helpful. So we knew we could do a lot better than that in the next year. So the next year's theme was hydrodynamics. Meet my team's new robot, Points, or to be more specific, Points 2.2. Although we did relatively well with this design, we knew it could have been, or with a previous design, we knew it could have been way better, and a lot of our frustrations with the forklift could have been prevented. So, during hydrodynamics, we took a look at all of our previous mistakes and the board. One of our mistakes was using a really big and poorly designed attachment. Although it was fun to have such a cool looking forklift robot, the attachment could only do two things: move up and move down. We watched different videos on YouTube and we decided to do some research. We basically looked up different robots that had previously won their competitions. First of all, I highly recommend that your team does their own research. But to help you out, I'm going to tell you a little bit about what I learned. We observed that the best robots have a system where they can attach many different arms. If you'd like to explore this further, check out the link in the description made by Welmpact Robotics. I hope I'm saying that right, so you can check that out below. Having a system where you can use many different attachments allows you not only to be able to move up and down, or to have one type of movement, but you can also move side to side or sideways or have something that pushes or pulls. This is super useful because the challenges are specifically made to test your robot's ability to do different motions, not just up and down. Another thing we learned was that a square-shaped robot, or as we called it, a box robot, was better. These boxed robots are easy to set up, easy to create attachments for, and the square shape is helpful for moving against a wall, or to push, or like to align yourself against a wall. The FLL Casts YouTube channel has some great videos for these box robots. Another design tip we observed was that everything should be as simple as possible. This sort of goes back to removing variables. My team made a guideline about robot attachments. The attachments must have the least amount of pieces possible. Generally, the less pieces means the less variables, less things that can break off, and generally the sturdier and the best that they're going to be. We also learned that the best wheels you should use are wide and medium sized. We initially used really thin and big wheels, but then we realized that not only do they have more of a sort of torque distance because the motors have a little bit of wiggle room, which makes it a little bit inaccurate, but we also learned that these big wheels without a lot of base room or room that like it's actually touching the ground, they slip more easily and that they're a lot less precise. It's also good to have your wheels encased. So this is sort of going back to the square robot or the boxed robot. You want your wheels to be inside of it, so you can use the sides of your robot as a bumper without having to mess the wheels up or to rub the rubber against the side of the board. Another tip is that the use of sensors, specifically the color sensor, will not only reduce variables, but it'll impress the judges. They're awesome. I highly recommend using them, and when in the future I'll create a video about literally coding the robot, and I'll talk about how you can use the color sensor because it's super helpful. Another thing to note is that all of the challenges can be completed with a standard EV3 design. There's plenty of videos of people programming the standard EV3 robot design to complete all the challenges, and they're all possible. But don't use this, and even if this basic robot can do it, it's not going to fly with the judges because part of it is creativity. Know that your robot doesn't need to be fancy to score points. In the World Festival, we met a team from Malaysia, and they had one guy who he had graduated, and his full-time job was to work on the robot, and they had this crazy, complicated, and amazing robot that could score tons of points, but it doesn't need to be that complicated, especially if you don't have somebody whose full-time job is working on the robot. So you can have a simple robot and still score awesome points. So, robot design is difficult. And not only should you observe what has worked best for past teams, but come up with your own ideas. Teams, please, please, please don't look up instructions to build a previously designed robot. Use creativity and teamwork and create your own. It's fine to be inspired by other robots, but don't just steal their ideas. Remember these things when designing your robot. Eliminate variables, simplify, and be creative. Designing a robot is difficult, and if you have any more questions or if you'd like to get some more resources on this, send me an email at thefllmentor@gmail.com. Thank you so much for watching this video.